starting our last major unit, our last unit that we will have a test for. We will hit a little bit of probability right before exams. There'll be a couple of questions on the exam, but we will not have a test on probability. So we will probably get to just a couple of days just to hit the highlights of that, because it's something that'll be on a lot of standardized tests. It's something that's great for you to know. So we're starting circles. We're gonna kind of divide it into two different sections, and so we'll probably do two different tests. We'll do a whole part on the angles of a circle, and then we'll do a whole part on the segments of a circle. As I told you, there is so much you could spend a couple of months on circles. We're not going to. We're gonna hit the highlights and then just keep on moving. But looking at your agenda, we will probably, it's in here, saying we'll do 10.1 today and 10. We're gonna start 10.2 today because today's a long day. We're gonna probably fly through 10.1 is my guess on looking at how it went last year. Start some of 10.2, we'll finish 10.2 tomorrow, and then 10.3 next week. Okay? Just to give you a heads up of how things are going. I am almost finished with grading this class's just triangle projects. Haven't even looked at those tests. That'll be the weekend. But trying to finish up those triangle projects since that was so long ago. Daniel, did you do one on fish?
Yeah.
Okay. Because there was no name. And I thought that was your hand.
Nice.
Just make sure. Okay? So let's get started. A lot of this should be reviewed. Be things that you already know about a circle. And so let's see what you know. We'll take a break probably in the middle and then keep moving. Alright, so first thing is how to define it. Well, a circle is the set of all points in a plane, so it's two-dimensional, that are equidistant. Big word. You can divide it into two words, equidistant. But one word, equidistant from one point. That point is called the, anybody guess? The center of the circle. Close. The point is the center of the circle. Okay? So a circle is defined as if you have a point, all the points that are equidistant from that one point. That's what makes it a circle. It is 2D. You think of a circle, guys, as all the things on the inside. The circle is actually just the, I don't want to call it a line because it's not a line, but the dark part, I guess. Okay? It is not, the circle is technically not what's inside of it. That's the inside of the circle. Okay? The circle itself is just the edge. Okay? So, the circle, when we name a circle, we always name it by its center. So, for example, we would call it circle, and we put a little dot in it, circle C, circle A. So you'll see that in notes, you'll see that on the test, you'll see that on homework, okay, circle C. So, if we talk about that, then if we say C is the center, it is a point. So you just put it, it's not going to be exact necessarily, but somewhere it's pretty close to the center. If we wanted to put point P on the circle, that's just anywhere on the perimeter, the circumference, but we don't call it perimeter or circumference, but anywhere on the, I want to say line, but it's not a line. Anywhere on the, what word could I use for that?
Outside.
The out, well, no, we're not talking about the outside. The rim, there you go, okay? Anywhere on the rim, okay? All right, if you wanted to talk about inside the circle, I think this is self-explanatory. You could put, sorry, that was point C is the center. Point C would be the center. Point A, if we wanted to put it inside, you could put it anywhere inside the circle. Point B, outside the circle, put it anywhere outside the circle. Just doing that to make sure, obviously that is self-explanatory, I'm pretty sure you know that. Okay?
It has to be those letters.
No, just if I'm saying point D is outside, wherever, just what's outside, what's inside, what's on the circle. Just making sure you understand. Right, what's on the circle, inside the circle, just the wording. Alright, there are lots of parts of a circle. Some of this you will have heard, some of it will be brand new to you. Okay? If I'm a segment that joins the center and the circle, what's that called? This one you probably know. It is the radius. Okay? It is the radius. And so it is a segment, so when I name it, I put the segment symbol above it. So we can talk about segment FC. Name another radius in that picture. FD, EF, or FE. Remember, with a segment, doesn't matter which way you name it. You could talk about EF or FE. Same segment, doesn't matter. You just put the symbol above it for segment. Segment symbol doesn't have any arrows, it's just a little line. Okay? If it is a segment that has endpoints on the circle, like segment, I'm going to go ahead and call this one AB, the endpoints of the segment are on the circle. Anybody know what that is called? This should be good. It is called a chord. A chord is a segment with the endpoints on the circle. So not only is there AB, there's one more in that picture. What's another one? Say it again. EC or CE. Same thing. Okay, because it is a chord with endpoints on the circle. It is a special kind of chord, EC is, because it is a chord that goes through the center. What do we call that?
Center chord.
Diameter. A diameter, good guess.
That's your first guess.
The diameter is the chord that goes through the center. So that would be EC or CE.
Sure.
Okay? Then we have two new words that you've seen the words before. Why they picked these two words, because we use them in the trig part, I don't know. Okay? But a line, so now we're not segments anymore. The line that intersects the segment, the circle at 2 points is called a secant. A secant is the line that intersects the circle at 2 points. So we could have line, and remember when you write the word line, or the symbol for line is the segment with the 2 arrows. So you could talk about line AB or line BA. Okay? You could talk about line EC even though it's not drawn to keep going. Okay? You could say that it keeps going, that EC or CE. It doesn't in this picture, but you could draw it extending it. Okay?
Yes.
And then the last one, the line in the same plane as the circle that will intersect the circle at exactly 1 point, like that one, is called a tangent. So here, my tangent line is DG. So it intersects it at only 1 point. Boys, hey guys, it's picking up everything y'all say on the video. So you're dead. Because you're closest to it. Okay? So guys, you could draw in tangents anywhere. You could come in here and you could draw a tangent over here. Okay? That would be C, and you could give it CX or whatever. So anytime it touches it at just 1 point. And we will, in the second part, learn lots of things about the tangent. Okay, we're not going to focus on that as much today, but part 2, when we get to segments, we're going to focus on angles, part 1, segments, part 2. We'll talk a lot about those tangents. Okay? So, you name this circle?
P. P.
Draw the symbol though, circle P.
Circle P.
Circle P.
Yes.
Name a radius.
SP.
SP or
QP.
PS. Remember, this is a segment. This does not have the line over it because it's stopped. What's another radius?
TP. QP.
TP
Actually, PT.
or,
PT.
we got that one?
QP.
QP.
I saw. Dang, you bring that blue. That was really cool.
Okay? You see that there are 3 radiuses. What's the diameter?
ST.
ST or TS, either way. What is a chord in this picture? There are 2.
QR.
QR is one,
ST.
and ST is one. Because a diameter is a chord. It's just the chord that goes through the center. A secant
ST.
goes all the way through and keeps going. So it is line ST with the line symbol above it. And then tangent touches it at only one point, so it is
Line UV.
UV. Okay, so now you see why this wasn't gonna take us too long. It's a lot of, not too difficult, just some new terminology. And the next part is also pretty much review. Okay? So, if you have congruent circles, you don't have to draw these, but if you have circle R congruent to circle S, what would you know about the radii of those circles?
Cool.
They're gonna be the same, okay? So, if they're congruent circles, they will have congruent radii. Radius is plural, is radii, like cacti. Is there any other words that do that? Cacti, radii? Hmm? Okay? The rest of this is some formula stuff we already know. How do you find circumference of a circle?
Diameter.
Pi times diameter, or,
R squared.
that's area.
2 pi r.
2 pi r. No. Either one of those. Okay? Pi times diameter, because remember circumference is like perimeter. The area, sorry, not area. Distance around a circle. Okay? So circumference equals pi times diameter, or 2 pi r. What's the area of a circle?
Pi r squared.
Area is pi r squared. This was supposed to be the second question. What is circumference of a circle? It's the distance around a circle. It's what,
The circular part
Right.
of the circle.
so can come down here and write it. It's the distance or the perimeter around a circle. That's what I was supposed to answer, remember? What does circumference mean? It means distance around. Okay, it means perimeter. How do we find it? That's the formula. 2 pi r. Okay? Yes. Look at Jason's look. Okay, so quick review. You can see that, guys, last time I did this before area, so that's why we're gonna kind of fly through this part because we've already done circumference and area when we were doing area. So, if the radius is 12 centimeters, what's the diameter? 24 centimeters. What would the circumference be?
24 pi.
24 pi, something missing, centimeters. Okay, it's just distance, so it's not squared. Area would be
144 pi.
144
CM
pi
squared.
c
Minus 120.
squared. Okay, area, you know, pi r squared. Circumference is just 24 times. All right, if the diameter is 15.5 inches. What's the radius?
7.75.
7.75
Inches.
inches. What would the circumference be?
15.5 pi
Inches.
15.5 pi inches. And I'm looking above, it said give exact answers for 2 and 3, decimals for 4 and 5. What would the area be? 15.5, sorry,
Yeah,
7.75 squares. Somebody in their calculator.
Wait,
That's
that's
what
We know what is
If you guys
7.75
didn't know,
squares.
calculate.
Hey guys, I can't hear.
60.065.
15 point.
One more time.
Oh.
What?
60.0625.
0.625
Yeah.
pi inches.
Square.
60.0625 pi r squared. So just rate 7.75 squared. You get 60. Alright, next one. If the circumference is 225 millimeters, let's go the other way. We're given the circumference.
Radius.
So circumference equals pi times diameter. So they gave us 225. So if circumference 225 equals pi times diameter, how do I find the diameter? Divide both sides by pi. So do 225 in your calculator, Evans, and it would get 225 divided by pi.
71.62.
71.62. Somebody check that, just so I have 2 people doing it, please.
Yes.
Thank you. Just because every time I do one, then I'll just hit one little button, and then it's messed up. Okay, so if the diameter is 71.62, how do I find the radius? Divided by 2, and you get 35 point what? 81 millimeters. So I'm just taking that and dividing it by 2. So then your area is pi, that radius, 35.81 squared. So 35.81 squared times 3.14, or times the pi button, and you get
4,000.
Oh my gosh, Jason.
concur?
Yeah.
Yeah.
One more time. 4,000.61. This one will be millimeters squared. Okay. Most of that's review. We've done circumference and area, because we did an area. Alright. Add a little bit from the last chapter. How do I find the circumference and the area of this? Number 5, example 5. What would my diameter, what would the diameter be?
2 root 2.
It would be the hypotenuse. So 4 squared plus 6 squared, right? So 4 squared, oh, what did I write? 4 squared plus 6 squared will equal the diameter squared. 16 plus 36 is 52. The direction said round that. Let's go to hundreds. One more. 7.21. So if your diameter is 7.21, you concur? Did you get the same thing? Then your circumference is pi times diameter. So 3.14 times 7.21. We're gonna multiply it out pi because it told us to give it in decimals. One more time.
22.65.
22.65. We don't have any units, so don't worry about units. And then the area is pi r squared, but I don't have my radius yet.
13 pi.
What's your radius?
The radius is square root of 13, but when you square the root of 13, you get 13.
Where it's square root of 13. Oh, cause you simplify, okay. We're just doing it in decimals, but you're exact, he took, if that's the diameter, he simplified that. That's 4 times 13. Okay, simplify the square root. Why are you looking at me like that, Jay?
Be like that. Do you understand it?
Ah, yes.
You didn't have to do this. Square root of 52 is 4 times 13,
Yes.
which makes that diameter 2 root 13. If I said exact, which I didn't, it said decimal, so that's fine. So if the diameter is 2 root 13, then the radius is just 1 root 13. This is half of the diameter. Okay, you didn't have to do this unless I said exact. Okay, so the
Very smart.
area would be pi r squared, so if I square square root of 13, it would be 13 pi. Okay, I'm doing that in different color because you didn't have to do it that way. But if we did it pi times 7.21, oh, it's a half of 7.21. Most of you did it this way. 3.6 what? 605, and square that for your radius times pi,
So 13,
and then times pi, and you get
oh, times pi,
Yep.
you get 40.83.
40 point what?
83.
40.83. Everybody okay with that?
Ooh, we have to do it.
You can do it.
So just as.
There probably will not be, because we just finished area. Last time I did this before area, so there probably will not be any. Okay, alright, next one. Nice one that looks very similar to what we've just finished. Given square ABCD with 4 congruent circles that are tangent to the sides, that just means it's touching it on its, okay? And if AB is 20, that means BC is 20. Means all the sides are 20. Can you kind of see your shaded region? Okay, some shades work, the next ones they don't. Okay? How do I do this? How do I find those circles? You know the area of the square. That part's easy. Because I'm gonna
The radius is 5. It's 100.
Yeah, the radius is 5, but the diameter is 10.
and they're gonna be 4 circles, so I'm actually gonna subtract 4 area of circles for the shaded region. So I'm gonna find the square and subtract the 4 circles.
Minus 400.
Area of the square is 20 times 20, so that's the 400. That's the easy part.
What's a circle?
Huh? Circle? You don't know what a circle is? A circle. Sometimes my brain works faster than my hands. Okay? I usually just do CIR. Yeah.
For the area of the circle, you just do the radius.
Yep.
And then
So how do I find those circles, boys? You were talking about it. What'd you
You know the
do?
diameter is 10 and the
The
radius is
diameter of each of these is 10. Because you see that it has to go all the way across, so they're all 10. So what's the radius of all those circles? 5. So I'm gonna do 4, so minus 4 pi, the radius 5 squared. There's 4 of those circles. So 400 minus,
200 pi.
one more try, 25 times 4.
100.
100 pi.
Good job, Aaron.
So 400 minus 100 pi. And you can leave it like that, that's fine with me.
Units in it.
Does that make sense? Boys, everything you say is on that video. Stop. Okay? Question? You can stop the video. That's the end of